The Hubble Space Telescope has created the most detailed and spectacular view of a neighboring galaxy to our Milky Way. A spiral galaxy nearly 3 million light-years away that is buzzing with star formation. Welcome back to Launchpad. I'm Christian Reddy, your friendly neighborhood astronomer. Well, it's winter time, and I figured it was about time to move inside and see if I can have a go at making up some kind of a home studio. It's a work in progress, but we'll see how it goes. Anyway, astronomers at the 233rd meeting of the American Astronomical Society released this spectacular image of the Triangulum Galaxy, otherwise known as M33. This image is composed of 54 separate images taken by the Hubble Space Telescope that were stitched together meticulously over a 2-year period. The result is a staggering 665 million pixel image. In fact, I can't even show you the full resolution because my computer would break if I attempted to render that in the video. Triangulum is located 2.7 million light-years away in about the same region of the sky as the Andromeda galaxy. Andromeda, Triangulum, and the Milky Way are the 3 largest galaxies in our local group of galaxies called the Local Group, which coincidentally was the name of my jazz punk fusion band in high school. It was an experiment. The local group consists of about 50 galaxies in total, the majority of which are small dwarf galaxies that orbit either Andromeda or the Milky Way. The Triangulum Galaxy is a classic spiral-shaped galaxy. However, it's puffier, consisting of more gas and dust, and belongs in the special subclass of galaxies called a flocculent spiral. It's also much smaller than the 2 large galaxies of the local group, containing only about 40 billion stars compared to the Milky Way's 100 to 400 billion stars, and Andromeda's 500 billion to as many as 1 trillion stars. Triangulum also lacks a central bar that connects its spiral arms to its central nucleus. It also seems to lack a central bulge, and this is a feature that is well defined in both Andromeda and the Milky Way. Andromeda and the Milky Way are also host to central supermassive black holes, each of which weigh somewhere in the range of 4 million to tens of millions of times the mass of our Sun. Triangulum, on the other hand, doesn't seem to have any such supermassive black hole at its center. But Triangulum does have the classic stellar disk consisting of very well-defined spiral arms. The difference in Triangulum, though, is that it's really poor in metals. That is to say, any element that is heavier than helium. So Triangulum represents a somewhat more pristine star-forming environment. That means its stars are not as contaminated by pesky metals such as oxygen, carbon, silicon, lithium, the kinds of things that we need for life. Not only that, but Triangulum doesn't seem to show any indication of mergers or collisions with other galaxies. So in some ways, it's a throwback to a simpler time in our universe when galaxies were undisturbed by their colliding neighbors. Now, this Hubble mosaic is very complementary to another mosaic made in 2015 of the Andromeda galaxy. Hubble captured a 61,000 light-year swath of Andromeda's disk, starting from the central nucleus, going all the way out to about halfway to the edge of the galaxy, and allows astronomers to compare star formation in Andromeda and in Triangulum. From our vantage point inside the Milky Way, we're not able to get an overhead view of our home galaxy. Andromeda, likewise, is tilted by about 30 degrees, but Triangulum presents us with a nearly face-on view, allowing astronomers to chart the evolution of stars across its entire disk. Now, we're going to dive deep into this image in a moment, but first, I want to take a minute to thank my first 3 Patreon supporters, Patty Broussard, Neil from Crypto Cruising, and Eric from Modern Day Family Man. Thanks to your generous support, I'm able to do videos like this. So thanks, guys. I owe you one. Now, one of the most amazing things about this image is that it shows off Triangulum's hurried rate of star formation. Triangulum creates 1 new star every 2 years, and that's about 10 times more intense than seen in the Andromeda galaxy. And this suggests that maybe Andromeda is in a relatively quiescent state, whereas Triangulum is busy just cranking out stars generation after generation. Now, among the regions of those newly formed stars is this one, IC 142. This is an example of a very large stellar association, a loose grouping of newly formed stars that are not gravitationally bound to one another. So even though they were all formed at roughly the same time and in roughly the same region, they're moving apart very gradually and will go on to take individual paths around the center of Triangulum. And speaking of forming stars, NGC 595 is an example of a star-forming region inside the Triangulum Galaxy. It's a region of ionized hydrogen and dust, which gives it its blue fluorescent color. But Triangulum is home to one of the most active star-forming regions anywhere in the local group. This is NGC 604, a 1,500 light-year diameter stellar nursery. It's one of the largest regions of ionized hydrogen anywhere in the local group of galaxies. The hydrogen is collapsing to form newer stars, but they're also fighting the outflow of intense ultraviolet radiation and stellar winds created by recently formed very hot blue stars towards its center. This new Hubble image is giving astronomers an unprecedented detailed look into the recent history of star formation in Triangulum. Astronomers will be able to make maps of the cool and dusty interstellar medium in between its stars, and define the temperatures and luminosities for some 15 million individual stars, not to mention identifying and cataloging some 1,000 individual star clusters within the galaxy. This new survey of Triangulum, combined with similar surveys of Andromeda, the Milky Way, and the Magellanic clouds that orbit our galaxy, will allow astronomers to paint a much more detailed picture of the formation and evolution of stars all across our local group of galaxies. That'll provide new insights into how stars form, live, and die all throughout the universe. Now, if you'd like to join me on this journey through this amazing universe of ours, well, please make sure to subscribe and ring that notification bell so that you don't miss out on any new videos. Until next time, stay curious, my friends.